Hello, Legacy students. Marsh here. So today we're going to look at number 6 on the day 2 rational functions graphing worksheet. You should turn to that question so that way you can follow along and write down as I write it down. Reason why I'm doing this problem, it has a little bit of extra information in it, so we want to make sure that we talk about it, and also just so that we can get a little bit more practice with this information. Maybe something else you might want to have open is the Strategy white paper, so you can follow along on there as I talk through the information. Okay? S, remember, S stands for simplify. In simplify, we factor. So let's go ahead and factor our information. So x minus 3 squared means I have to write it twice. So I'm going to write x minus 3 twice. And then I'm going to write x plus 2, like that. Over, now the denominator, I have to factor the denominator, x squared minus 4. So I'm going to factor it to be x plus 2, x minus 2, just like that. Now, notice, we have something on top and something on bottom. So we got to factor both of them, not even factor both of them, but cancel both of them. And then I'm going to rewrite my problem. I have x minus 3 on the top, and x minus 2 on the bottom. Okay? Now, something is canceling out, which means we have a whole, right? We have a whole. So I'm going to set what we canceled out, x plus 2, equal to 0. So I'm going to say x plus 2 equals 0. And I'm going to solve for x. I get x equals -2. Now, I need to find what y connects to that x. So to do that, I'm going to take this -2 and I'm going to plug it in for the x into my simplified version. So I'm going to make some room over here because I don't have a lot of room over there. So I'm going to go -2 minus 3, -2 minus 3, -2 minus 2. Okay. I'm going to get -5, so the top will turn into 25 once I multiply, right? Bottom, I'm going to get -4. -25 fourths does not simplify, so my ordered pair of the whole on this graph is -2, comma, -25 fourths. Yuck, right? But nevertheless, it is the ordered pair of the whole. So I'm going to go -2, -25 fourths, that is -6 1/4. So I'm going to go down right here, put the dot right there. Okay? My roots. Now, before this, when we got a whole on day 1, you were like, oh, perfect, Marsh, look, we don't have to graph Strategy anymore because it was a linear equation. Now, looking at this one, it did not go down to a linear equation. It stayed a rational function. So I have to keep going with Strategy because it's still a rational function. So with our R, remember R stands for roots, which means we need to find our x-intercepts. So to find my x-intercepts, I am going to set the numerator equal to 0. So I'm going to set x minus 3 equal to 0. I'll get x equals 3. I'm going to write an ordered pair because it's an x-intercept. 3, 0. And over on my graph, I'm going to put a little dot there. Okay? A stands for our asymptotes. Remember, to find the asymptotes, we are setting the denominator information equal to 0. And remember, I'm not using the original, I'm using my simplified after I canceled out. So I'm going to set x minus 2 equal to 0. I'm going to get x equals 2. So I'm going to go over here on my graph, and since that's a asymptote, a vertical one, because it's x equals, I'm going to draw myself in my vertical asymptote. Just like so fashioned. There we go. Now, t squared. Remember, t squared, or any of the t's, you're looking for doubles. You're looking for doubles in the numerator. You're looking for doubles in the denominator. I notice that there is doubles in the numerator. We have the same thing twice. And remember, that means you have tangency. So we're going to make a little note that we have tangency. And when we have tangency, that is for an ordered pair that we have tangency. We have tangency at an x-intercept. So I'm going to make note that the thing that doubled up would have been the x-intercept of 3, 0. So I'm going to make a little note. Tangency at 3, 0. Why is it 3, 0? That's because that is what was doubled up. I doubled up x minus 3 in the numerator, which gave me a root of 3, 0. That's why I'm saying that I am tangent at that point. What does it mean to be tangent? That means instead of going through the x-intercept, you're going to bounce off of it. Okay? You're not going to go through the ordered pair right here. You're going to just bounce off of it. I just realized, you know what I realized, guys? My hole on my graph here, that should have been an open dot. And I bet you guys were telling me that. You were like, hey, Marsh, there should be an open dot. Can't get my pen. There we go. I'm going to go change that. -2, -25/4. There we go. Whew. Almost made that mistake. That's a hole in the graph, which means it should be a open dot, right? E. Oh, excuse me. We need to do togetherness. There is nothing doubled up on the top, so no togetherness, right? None in the togetherness department. So that means around this asymptote, one of the sides is going to point towards infinity or point up. The other side's going to point down or to negative infinity. E, remember E, we first have to look at the degree of the numerator and the degree of the denominator. And I got to look at this simplified. I'm not going to look at the original because I canceled out stuff. So my original, I have a degree of 2 if I FOILed that out, and a degree of 1 on the bottom. So I am top heavy. Okay? If I'm top heavy, that means we have to long divide. So I'm going to long divide the simplified version. I'm going to simplify or divide x minus 2 by, and I'm going to FOIL that numerator. So I'm going to get x squared minus 6x plus 9. Okay? Now I'm going to do my long division. Something times x is x squared. I'm going to get x. X times x. X times -2, change my signs. I'm going to get -4x plus 9. I need to ask myself, something times x is -4x. That would be a -4. Change my signs. I'm going to get a 1. Now remember, when we're finding our slant asymptote, I don't care about the remainder. All I care about is what we get for an answer. So my slant asymptote is at y equals x minus 4. I'm going to go graph that line. Oh, almost went through the hole there. That would have been good. Fix my hole there a little bit. Okay. Hole should be on the bottom of that line. Whew. Okay, C. Remember, C, you are checking to see if the function crosses through the slant / horizontal asymptote. So I'm going to set the S equal to what we got for E. And I'm going to do it over here because I don't have enough room over there by the C. So I'm going to set this, so what I have for S, because I simplified, equal to what I got for my E, which is x minus 4 over 1. I'm putting it over 1 because I need it to be a fraction. I'm now going to cross multiply. I'm going to get x squared minus 6x plus 9, that's that guy times that guy, equals these two, which is x squared minus 6x plus 8. I just FOILed those two together. Notice, if I add stuff to both sides, x squared and a negative 6x is going to cancel out. I will get 9 equals 8. That is not a true statement, so my C does not cross. I am not going to cross through my slant asymptote. Y, we're going to plug 0 in for x. Again, please make sure you plug it into the simplified version. So I'm going to plug into 0 minus 3, 0 minus 3, 0 minus 2. I will get 9 over negative 2. So my y-intercept is 0, negative 9 halves. So I'm going to go put that dot over here. That is right here. Okay. See if I can make my graph zoom in a little bit. There. Now it's easier for us to see. Now, looking at this. Oop. Oh, that's sad. Didn't let me stay zoomed in. Okay. I am noticing I have a hole and I got this dot. I have to connect those dots, but I can't cross my slant asymptote. I can't cross my vertical asymptote. So I'm going to go through there. I'm going to change my color of pen here so it's easier for you guys to see. I'm going to go through the hole, through there, and then I know it's got to turn around some point. I don't know where because I don't have that dot. So I'm just going to be sketching. I'm just guessing. I'm guessing it's going to get kind of close to the middle and then turn around and go down, just like that. Now, I need to remember, where is his friend? Now, can't be on top of him, right? Can't be on top because that's then not a function. So then I got to figure out, is it on this side or is it in here? And we have a dot there, so I have to use that dot. So it can't be over here, plus we don't have togetherness. And if I drew down here, they would be both pointing down around that asymptote. So I need to draw here. Now notice, right here, we said we were tangent at that dot, which means I can't go through that dot. I have to bounce off of that dot, which makes 100% sense, right? Because I literally have to almost draw a V again. So I'm going to draw my V. I get to that dot, and I'm just going to boo off of it. I'm just going to bounce off. We're not going to go through it. We're just going to bounce off of it. I now have my picture. I got to write my domain. Now, most of the time on the last couple of problems we've been doing, we've been looking at the vertical asymptote, and that's the only thing that causes the problem, right? But we have another issue. We have that hole that's going to cause a problem in our domain. So we have technically two problems of the domain. We have a -2 problem, that's because of the hole, and then we also have a problem at 2 because of the vertical asymptote. So I'm going to notate my domain is from -2, or negative infinity to -2, -2 to 2, and I'm going to go below 2 to infinity, just like that. Range. Now, range, you're probably like, well, Marsh, the hole's going to cause a problem again, right? Because there's an open dot there. But the range is a little different because if you look at your graph, notice that y value I have right here. So that y value of the hole, technically, there's not a problem with it because the graph drew on that same y again. So I do have a problem though, right? Try to draw myself a box here. Right here. There is no picture that I just drew in there. So I have to say that information when I am doing my range. So I'm going to say that my graph starts at negative infinity. And you know what? It stopped right about here, which is very close to I don't know, negative 3.25, negative 3 1/4, something like that. And I'm just guessing that number. I don't know for sure if that's actually the answer, but based on my picture, I'm seeing that as my picture. So I'm going to say negative 3.25, and I'm going to put a bracket on it. Now, maybe you didn't turn around as late as I did. Maybe you turned around only at negative 4. So then you would say negative infinity to negative 4. You're going to want your range to match what your picture is doing. And then I'm going to say union. I started at 0, because on the y's. So I'm going to make note. I started at 0, and I went to